point here. Okay, so I try to build up a few scenarios and to fit into that criterion and see what happens. Okay, so for the scenario, the first one is for the prevalence here, if we consider is in its principal orientations, and then we have the principal stress, sigma 1 and sigma 2. Okay, so sigma 1 and sigma 2 are the principal stresses. So to get into here, basically you should be able to convert any design problem, any distribution of the stress into these directions. So the discussion will based upon this one. The scenario 1 is this: if sigma 1, they both are negative, and sigma 1 is greater than sigma 2. So that means the Moore circle will be this case. I think I'm going to use this side as my scratch space, and then put the result here. Okay. So for the first case, the Moore circle is like this. So this is sigma 1, this is sigma 2, right? I think in this way, my statement is not so complete. We can still stick with this one. Will it be okay? Let me generate the result. Keep this one. Okay, if we work on the 2D stress problems and here, and that is this case. And for this case, and actually this is the two-dimensional stress scenario, but if you see this one, if we for this case, if we are able to extend into the three-dimensional case, and that one here, I simply extend the case into the outward direction. That means going here. So this is here. This is sigma 1 here, and this is sigma 2 here, and this is the sigma 3. That's supposed to be 0. Okay, so that's the 2D case. So for this case, you can see we have the 3 circles. And for the black one, this black one corresponding to is a person. He sit onto this axis and looking downward to look at the distribution of the stress, and then corresponding to the black one. The green one corresponding to is the person sitting into this axis and looking into this direction. So once he look into that direction, what he see is only sigma 2 and 0 here. So based upon this, we have a more circle corresponding to the circle one, the green one. And for the red one, and again, we're changing this. The red one is sitting on this axis looking into that, and so that corresponding to what he see is sigma 1 and nothing else. So this one corresponding is this one. So from here you can see what is the maximum, what is the maximum stress. So for this case, you can see this one, the radius of this one is our maximum. Okay, so that means the maximum here, for example, here is sigma 1 divided by 2. Okay, so for this case, we are asking is this. For the criteria, here we have is sigma 1 divided by 2 is less than 1 over sigma y. So that means sigma 1 less than sigma 1. Okay, so for example, at the onset of the failure, for example, here we put an equal sign here. That gives us the boundary at which we shouldn't be beyond, and that gives us the boundary here. So for this case,
Why wouldn't it just be like, you know, less than or equal to?
Yes, let me draw this one quickly here. I want to draw the boundary to margin the boundary beyond which the risk will be there. So let me put into here the drawing. So this is the sigma 1, sigma 2 space. So for the first scenario, the boundary is here, the sigma 1. Then, okay, so that is these boundaries. Okay, so I'll mark this one here. And so sigma 1, sigma 2, so the boundary, so right now we're talking about is in this space, and we have a boundary here. And for the second scenario, we're going to study is sigma 2 greater than sigma 1 greater than 0. So right now for the second scenario, we're looking for is this domain. Okay, and similar reasons to this one, you can see the maximum shear stress should be sigma 2 over 2. Okay, and then at the boundary, this one is sigma 1. So that means sigma 2 equal to sigma 1. That is the boundaries. So that is this page. Okay? So that means as long as your application of the design, your stress, your principal stress, locate anywhere, for example, anywhere inside this area, then you are safe. If your data point is falling outside this boundary, for example here, then you might consider that might be risking. We didn't say the material will definitely go to fail, but it's risking the design life. Okay, and then the next one we can try is this one. So that means here we're looking for is this value, this domain. Okay, so the third scenario is looking into the space. In this way, we try to find out the design and the maximum. For this case, the maximum equal to because right now it's negative, and here we're looking for is the values of the maximum. So that should be, if you can continue using this figure, what will be the maximum, the value of the maximum shear stress here? Should be sigma 2. Sigma 2 will give us the biggest circle, but right now the sigma 2 is the negative, so we put a negative here. The whole thing will be a positive value for maximum shear stress. Will that be right? Okay, and then sigma of this is equal to sigma 1. So therefore, sigma 2 equal to minus sigma 1. So that will be equal to this one here. So this is the minus sigma y. Okay. probably coming back next week, let me finish the other scenario. Basically, I'm going to cover the whole project for making the boundary, and inside that everything will be the same. Okay. Great. And remind me, start from the case.